Hello, this is Daeyoung Gil, PhD from Yonsei University in South Korea. Today, what I'm going to talk about is one-shot indoor localization using the 360-degree portals. Yep, with the significant increase of human labor costs nowadays, the recent construction industry is trying to adopt the robotics in site monitoring. Now, among the many applications of robotics in construction, autonomous monitoring is one of the major and prevalent research domain. Using the omnidirectional camera can capture the old visual features, visual information from all the direction without being affected by viewpoints. And also it enables the reliable data extraction even when a robot moves around and autonomously. Although using a omnidirectional camera allows for autonomic, flexible angle adjustment nowadays, but determining the precise location where the image was captured is a separate challenge. That is the issue we address in this study. I'm going to talk about this study, how it is going on, and also here we present a method determining the capture location of images with the residential building characterized the repetitive floor plan. Previously, various efforts have been attempted to attempt to locate the location of photos taken. Compared to sensor-based indoor localization like Wi-Fi, ultra-wideband, or RFID, that kinds of things, visual-based indoor localization has an advantage of not requiring prior installation of sensors, those kinds of sensors. Therefore, portal-based indoor localization is quite cheaper and more practical than sensor-based ones. Most previous visual-based localization approaches use the method of comparing the similarity of the previous given input photos with the prepared reference photos. Nevertheless, such methods has showed the quite robust performance and quite good performance, but such a method require the preparation of large image data set for training the models, and also some kinds of approaches depends on the camera parameters to be adjusted. So in this study, we propose two processes to achieve robust indoor localization using omnidirectional camera. The first one is a method of alignment procedure to adjust 360-degree photos, camera parameters, and the second one is a comparison method to compensate for the distortion inherent by equirectangular photos to represent the 360-degree photos. First, we align the image orientation by shifting the image input images using feature matching with an ensemble feature descriptors. Feature matching was employed to calculate the shape distance for image alignment. References images are previously configured via cube map projection so that each projected faces are correspond to a single wall. By doing so, input images are similarly shifted to these kinds of orientation to facing each wall. Next, distortion resulting from different capturing spots within a room are mitigated by using CMP, cube map projection-based comparison. For each room, pre-captured photos, equirectangular images the input photos are both projected into these 6 cube map faces, and the similarity scores are computed for each corresponding face. These face-wise approach scores are then averaged to yield an overall similarity score. by repeating this process across all candidate rooms, such like living room, balcony, kitchen, bedroom, bathroom, the kinds of things in this portal. The rooms with the highest average similarity is identified as the image captured location. For the experiment, the data set is composed based on a typical residential building in South Korea. It has various room space like a bedroom, dressing room, kitchen, and so on. We conducted experiments across 6 residential units featuring different floor plan types. Each unit included similar room categories, but there's some slight variation in their floor plan type in spatial layout. We evaluated various machine learning ML-based feature descriptor models to identify the most effective for our application. As you see, ORB, Brisk, Akaze, local feature transformer, and also we, on average, Brisk-based approach outperformed all other tested ones, and also it showed the surpassing performance rather than transform-based one, local feature transformer. To further enhance performance, we employed an ensemble descriptors for the feature matching, combining ORB, Brisk, Akaze, and it ultimately yielded the best performance among them. We initially conducted the proposed method with only one-shot approaches, but however, it have the possibility to be improved by using more portals. When we utilize one-shot approach, about 72% of accuracy is achieved, but we could achieve more than 86% of accuracy by using 5-shot learning. It means that we may be able to get more improved performance by using more portals. Also, the evaluation study demonstrates our proposed method, 2 kinds of proposal techniques operate synergistically. When either the image alignment and CMP-based comparison is omitted, then performance of our proposal is dropped near a random level. So it means that the proposed 2 methods perform synergistically. The proposed indoor localization method is distinguished by its focus on context, delivering spatial context as a human-like approach. We intended to apply this spatial context framework to management of indoor defects. In fact, through our statistical analysis, we have recognized that the cause of mold defects, especially mold defects, are intrinsically linked to the linked to the location where they occur. So we are conducting a research that employs features to infer the root cause of mold defects from their detected location, as like that. To summarize, through our work, we propose one-shot and few-shot approach to recognize where the portal is taken. To make it, we may have to align the given portals not being affected by camera parameters. So, and also we made sure the method of comparison of 360-degree portals by CMP-based approach. For that, it has an advantage to recognize contextual location in residential building, but still requires more robust and more accurate performance. We are striving for that. Future research of ours will be focusing on that kinds of things and also identifying more application for further study. Here's our acknowledgements and references. This all I prepared for today. Thank you for listening.